So hi everyone, thank you so much again for joining us. This is the NSAA Admissions Assessment Workshop with Corpus Christi. My name is Ellie Robley. I'm the admissions coordinator here at Corpus Christi. So I'm the one that you'll be emailing and we'll be getting lots of emails from. I'm gonna not delay this any further and introduce you to our wonderful admissions tutor, Dr. Michael Sutherland, who will be presenting today. So I'll pass right over to you.
Great, thanks very much, Ellie. Thank you all for attending this session. Just to give you a brief overview, we're going to go through some of the backgrounds of the NSAA, so what it is, how we use it. I'm going to give you some resources that you can use to prepare for the NSAA, and we're going to go through and just solve a couple example questions, so you can get a sense of the style and in particular the timing around the NSAA questions. So just a bit of background, I'm the admissions tutor here at Corpus Christi College, but I'm also a physicist and I work in the area of low temperature physics, where I'm interested in how electrons behave at very high magnetic fields and very low temperatures. So be very happy to also to answer any questions on quantum physics if they should arise, but mainly we're going to be focused here on the NSAA. So I'm going to just share my screen now. I have a brief presentation that I've put together, and hopefully you can see that. Yep, that looks to be okay. Great. Okay. This is a picture of Corpus Christi College. This is New Courts, taken by one of our students, just to give you a sense of the college if you've never visited. It's one of the older colleges situated right in the heart of Cambridge, and it's quite close to many of the lecture theatres and laboratories you would be using if you were a natural sciences student. So let's first talk very generally about what it is that we look for in a Cambridge applicant, because that frames our discussion of the NSAA rather well. So in Cambridge, we're looking for academic ability and for academic potential, and that means things like logical and independent thinking, intellectual flexibility. So can you change your ideas when you see new data? And the ability to think critically and analytically. And that's particularly important if you're applying to a course like natural sciences. We're looking for students that demonstrate some degree of genuine personal interest. So they're very keen biologists or chemists or physicists. And students that have an enthusiasm for complex and challenging ideas. So they don't shy away from perhaps a more difficult topic. They like to embrace that. And work hard to understand it. So also important, but perhaps less so for something like natural sciences, is evidence of vocational professional commitment. So that's really only for the medics. It's difficult to get work experience as a physicist or chemist, so that doesn't really form part of what we're looking for. But it's mainly this academic potential, academic ability, and that genuine interest in your course. So how do we assess our applicants, given what we've just discussed, what we look for? One thing I want to emphasize in Cambridge, all of our decision making is done in sort of a holistic way. So that means we look at all the information we have available for a candidate before we make a decision, and we try and build up a picture individually of each candidate's strengths and weaknesses. And the sorts of things we have available to us as admissions tutors and directors of studies. We have your academic records, so we know how you've done in GCSEs and other relevant qualifications if you've taken them. We have your personal statement, which we read, each and every one of those. We have the reference from your teachers, so we're interested in what your schools are thinking. Written work, not really so appropriate for NSAA. For natural sciences rather. And then we look at performance in the admissions assessments like the NSAA. We look at contextual data. So that means how you're doing with respect to the students from your school. So are you in one of the top students in your cohort? And then finally, we look at performance at interview. And we build up a picture by looking at all of these different pieces of information when we make that admissions decision. So why is it that we ask students to write an NSAA or a pre-interview assessment? Well, we are rather fortunate at Cambridge in that many students want to study here. Most of the students look very, very good on paper. So predicted multiple A stars, they've done perhaps quite well in their GCSEs. And just looking at last year's data from 2020, we had around close to 3,000 applications for natural sciences. We ended up making around 700 offers. You know, the NSAA just gives us an additional piece of information, and it's taken, you know, a data point right at the beginning of your year 13. So it allows us to see how you've managed that transition from GCSE to A-level. So it's another piece of data that we use, but it's not the sort of end all and be all of an application. It's possible not to have the NSAA go spectacularly well, but do well in other aspects of your application and still receive an offer. So there are two types of assessments that we run at Cambridge. The ones that you're interested in are mainly these pre-interview assessments. So these are the ones that take place prior to coming up to Cambridge for an interview. The registration deadline for the majority of these, including the NSAA, is October 15th, and the registration is handled normally by your school. So you need to speak to your teachers, let them know you're applying to Cambridge, and they should be able to get you registered for the NSAA. This year, the tests are going to be sat in schools on the 3rd of November. It's a little bit later than previous years, but that is something to be aware of, that particular date. So you've got just over a month now to prepare. I would add that some colleges, I'm thinking Trinity and Magdalen College in particular, will also give you a test at the interview stage. So if you get called through to the interview, they'll ask you to write a college-specific test, just some more problems to work through. We don't have a test like that at Corpus. It's just the NSAA. So just be aware of that and check individual college websites for details. So one of the first pieces of advice I would give in thinking about the NSAA is it's really important to know what you're being asked and to appreciate and understand the format of the test. It is slightly confusing because the NSAA has changed format slightly a few times over the years. So some of the past papers that you've seen, well, the content is still good. The format of the questions and the timing will have changed slightly. It was introduced back in 2016. The format changed a little bit in 2019 and then again in 2020. But the format as it stands now, so for this coming round, will be a test that is 2 hours in length and has two sections, section 1 and section 2. Within section 1, there are 4 parts. So there's mathematics, physics, chemistry, and biology. Every candidate for NST, whether you're interested more in the sort of biological sciences or chemistry or physics, everyone has to do the mathematics component and then choose one other part. So if you think your main strength is in chemistry and that's what you really are interested in taking in perhaps later years, you would choose in section 1 to do mathematics plus chemistry. So make sure you think a little bit about that and choose the section that you think you're best at, where your strengths lie. In section 1, as I said, it's 60 minutes, so 1 hour in length. You get 20 multiple choice questions in each part. So you get 20 mathematics questions, say, and 20 chemistry questions, and you have only 60 minutes to do them, to answer 40 questions in total. So that you can get a sense right there of the time pressure. It's just over about a minute and a half per question. So you really got to get through these questions pretty quickly. It's all multiple choice there. And another thing to note is that there's no calculators used on the NSAA. Section 2, there are 3 parts of section 2, 1 in physics, 1 in chemistry, and 1 in biology. Here you just choose one part. So these questions are a little bit more open-ended. That you have a little bit more time to think about them and to work through some of the things that they're asking. So there again, you should choose the section that you feel most confident in. So you don't have to revise all of physics, chemistry, and biology. You would just choose, say, biology if that was your main subject of interest. So just be aware of that. Here, there are 20 multiple choice questions, but you have 60 minutes to do them. So there are 3 minutes per question. So questions, have a little bit more time in section 2 to work through, but they do tend to be a little bit more challenging. And again, no calculators in that section. So that's the format. Now, let me just tell you a little bit about the specification. So you can navigate to the university website. If you just sort of Google Natural Sciences, Cambridge University, you'll get to this page here. And you can click through and find the specification for the Natural Sciences Admissions Assessment. And you can download this document. It's a PDF, and that's what it looks like. And I think this is a really good thing for you to have a look at the beginning of your revision for this test. Because what it does is it goes through in really gory detail every single thing that you need to be competent with to do well in these tests. So for instance, I've just called up a little bit here from the mathematics part of the specification. This is for section 1, and section 1 mainly is drawing on GCSE material. So if you go through, you look at it, for instance, you would be expected to use standard units of mass, length, time, money, and other measures. You would be expected to use the concepts and vocabulary of prime numbers, factors, multiples, common factors, etc., etc. So as a great way to start your study, have a look at the specification and just put a kind of check mark by the ones that you're pretty confident with. I mean, I think hopefully everybody knows how to add, subtract, multiply, and divide integers. So you could easily put a check mark by that one. But then you can also perhaps find the areas where, thinking back to GCSE, maybe you didn't quite understand a concept or you just need to revise it. So you can identify the key areas where you're not so confident and just concentrate your revision on those. As a further example, here's some biology specifications from section 1. So you should, for instance, if you're doing the biology part of section 1, you should know what a cell membrane is, a cytoplasm, a nucleus, mitochondrium, etc., etc. And then for section 2 in the specification, it draws a little bit more on year 12 material, or what used to be the old AS levels. So here I've just shown a little bit of what's expected for chemists. In section 2, you have to do things like define first ionization energy and write equations for first and successive ionization energies. So if that's something you feel confident about, great. You don't need to revise. Maybe just refresh your memory a little bit. But if it's something that you didn't really understand the first time around, that's something you're going to want to concentrate on. So use this specification as a template for your revision over the next month. And again, that's just available on the university website. Okay, let me move on now to talk a little bit about exam strategies. So this exam is different than the sorts of exams that you may have expected, for instance, for GCSE or A levels. Now, I know exams have been disrupted many times over the past few years, but you probably have seen past exam papers, for instance, for GCSEs. These exams are a little different because students are not expected to get 100% or very high marks on these exams. Indeed, most students would probably get around, say, half of the questions, if that. So they're designed to be quite challenging. They're designed, for us to stretch the field out. So very few students would be getting top marks. But most students would be getting somewhere, around half or perhaps slightly less than half of the questions right. So don't get discouraged. Don't panic if you're trying past paper questions and you're thinking, oh, I'm only getting half of these correct. Well, if you're getting half of them correct already, then you're doing pretty well. So how to approach the NSAA? Well, as I mentioned, it's very important that you choose in advance the sections you would like to answer. And we talked a bit about the structure there, and factor that into your preparation. There's no point in spending hours and hours and hours revising chemistry if you're not going to answer the chemistry sections on the NSAA. So think of that in advance. Be aware of the time constraints, which we've talked about. And then because this is a multiple choice exam, and you're not penalized for wrong answers, think about your multiple choice strategy. So for instance, on a multiple choice exam, do you start at the first question and work through sequentially? Do you start with the easiest questions? So you skip through and you say, well, 1, 6, and 8, I think I know how to do, I'll finish those, and then move on to the harder ones. Or do you prefer to get the hardest ones out of the way and then move on to the easier ones? And I think people will have different styles in how they answer their questions. Personally, I prefer the second option there. So if I'm doing a multiple choice exam with lots of time pressure, I scan through the questions, the ones that I'm sure I know how to do, and just get those out of the way. And then when there's a bit more time at the end, I go back and do the ones where I was a little bit unsure. But whatever works for you, but think carefully about that strategy and just be aware that this time pressure is quite significant. So some advice for on the day. So when you're actually writing the exam, I always advise students for any type of exam, make sure you know when and where the exam will be held. So get all the practical arrangements. It's going to be in classroom A at 12 noon or whatever it is. Just so that you're not panicking and trying to find the exam room, 5 minutes before it starts, because that kind of gets you flustered and you don't start the exam in a good frame of mind. So be 100% sure of all the practical arrangements in advance of the exam. I always advise students to get a good night's sleep before exams. There's lots of data that shows if you only get a few hours of sleep, your abilities to perform complex tasks, i.e. mathematics, that diminishes. So, there's no point in burning the midnight oil, staying up till 3 a.m. to squeeze in the last bit of information. The night before the test, put your books down at 7 or 8 p.m. and go and watch some Netflix or something, because by that point you've done all the revision I think that you can possibly do, and a few extra hours of squeezing things in isn't really going to help. One piece of advice, and I think this is quite important, when you're writing an exam under time pressure, sometimes you get a bit flustered and you're scanning through the question really, really quickly, and you misconstrue what is being asked. So make sure you read each question through carefully twice before answering it. And it might be something very trivial, like the question could be asking you to find the area of the rectangle inside of the circle, and you misread it and think it's the circle inside of the rectangle, and you spend a couple minutes doing the wrong calculation, when what was being asked was actually pretty straightforward. You just misread the question. So that can really pay. I know you're trying to move fast, I know there'll be time pressure, but just really concentrate and make sure you understand that question before you fill in that multiple choice bubble. So 4 questions that you're unsure of, and you've probably heard this before, see if you can eliminate 1 or 2 obviously incorrect answers. So usually there'll be somewhere between 5 and 8 possible solutions to a multiple choice question. Often there are a couple that are just completely ridiculous. So there'll be a speed that's faster than the speed of light, or a length that's longer than the perimeter of your rectangle. So sometimes there's a couple answers in there that are just clearly wrong. And once you cross those out, if you've got 6 and you can cross 2 out, then there's only 4 left to choose from. Even if you randomly guess, your chance of getting a correct answer is improved, is 25%. So that can be a useful strategy for those questions that are, you're a little bit stuck on. Rule out the really, obviously incorrect answers. Now, just keep in mind, finally, that the NSAA is just one of the elements that we use. And I talked about that a little bit at the beginning. And we routinely admit students who, do fairly well at the NSAA, but, not brilliantly. But obviously, if you do well in the NSAA, it is certainly something that looks very favorable on your application. So you should revise appropriately. Okay, now I'm going to switch this over now. I got to switch over to my iPad, so this could take a second. And what I'm going to do is have a look at a couple example questions from last year. And we'll just go through and try and solve them. Now I'm, hands up, I'm a physicist, so I'm going to be doing a maths and a physics question, but it will hopefully give you a little bit of a sense of the timing issues around the NSAA. Okay, so if I now go here and here, good. Hopefully you can see this question. Okay, so this is a question from the 2020 paper. This is a section 1 mathematics question. So again, in that mathematics component, section 1, all students have to answer that. So even the biologists and chemists. And the question is as follows. So we've got this square here, PQRS, and M is the midpoint of this side PS. We've got a circular arc with center M, and it's drawn inside the square from S to P. So it's this thing here. And then we've got another circular arc, which is a little bit larger, and it's drawn with a center P all the way from Q down to S. So it looks a little bit like that. And it's asking us what is the area of the shaded region in terms of X. So hopefully we can look at this and think, well, the key here is they're talking about a circular arc. So immediately you start thinking about circles, and you can probably spot that this is a part of a larger circle, subtracting away a part of a smaller circle. So if I call this larger circle here, if I call this 1, the area of 1 is going to be, it looks like it's a quarter of a circle, so it's 1/4. And then we know that the formula for an area of a circle is pi r squared, so pi, and we just have to find out the radius of this. So the radius of this big circle here, it looks like it's the full length of the square, and we're told that the square has sides x, so it's 1/4 pi x squared. And then we need to look at this thing here, so we'll call that 2, so that's area 2. So A2 is equal to, well, this is a half a circle, so it's got a half and pi, and then we just need to know the radius there. And the radius, well, the diameter of this thing is clearly that whole side of the square, that's x, but we're interested in the radius, so we're interested in half of that. So that's x over 2 squared. So the total area that we're looking for, the shaded area, is going to be equal to A1 minus A2, which in this case is equal to pi x squared 1/4 minus 1/8. So that should be pi x squared over 8. So if I look down here, oh, it seems to be the first one. Okay, so that answer there is pi is A, pi over 8x squared. So that's an example of a question that you would have 1.5 minutes to do. So not, mathematically particularly challenging. It's just some GCSE mathematics here. But remembering to read the question very thoroughly, you don't want to get mixed up in getting a factor of 2 error off. It can be a little bit challenging to get this done in a minute and a half. So lots of practice is needed. Okay, let's have a look at a section 2 question, just to get an idea of what one of these slightly longer questions looks like. So I will now look at this question. Okay, so again, this is from 2020. This is section 2, the physics part. So we have about 3 minutes to do this question. So let's read it through. It says 3 identical resistors can be combined in 4 different arrangements. One of these arrangements has a resistance of 18 ohms. A different arrangement has a resistance of 8 ohms. What are the resistances of the other 2 arrangements? Okay, so you can kind of see right away that it's not as straightforward as the first one. You do have to think a little bit about this, but let's start with the first part of the question. The first thing it says is, we've got 3 identical resistors can be combined in 4 different arrangements. So maybe let's work out what these arrangements are. And now when I think of resistors, I know that they can be combined in series, so the current flows through each one together, or in parallel, so the current splits in 2 and then flows through the 2 resistors. So I can imagine, I'll call this, well, let's draw a little picture here. There's resistor 1, resistor 2, and resistor 3, and these all have resistance R, and this is all of those resistors in series, so I'll call that configuration 1. And then I can think of perhaps having the current split like this and go through a resistor here and a resistor here and coming back together and going like that. I'll call that configuration 2. And then configuration 3, I can imagine having all of these resistors all in parallel, like this. So I've got 3 parallel resistors, like that. And then it just took me a second to think of the fourth one. So the fourth one, you could imagine having 2 resistors like this, and then this one being in parallel here. Okay. So those are the 4 possible configurations they're talking about. And note that little hint at the bottom of the question. All 3 resistors contribute to the total resistance in all arrangements. So that discounts some crazy circuit where you like just stick the resistor off somewhere else and it's not contributing to the overall resistance. So the current is definitely flowing through the resistor, and that's why we can narrow it down to these 4 configurations. Okay, so probably the next step here is to work out what the resistance would be in each of these configurations. So I think in configuration 1, we'll call our resistance R. We would just have R plus R plus R, and that gives us 3R. Configuration 2, well, we've got 2 of those resistors in parallel, and we can remember to add resistors in parallel, you need to do this, and then 1 in series. And so if you work that through, it's going to give you 3R over 2. And then the third configuration, well, that's all of these guys in parallel. So we do this one. And that would be R over 3. And then finally, the fourth one, we've got 1 over R, because we're combining these 2, and then 1 over 2R. So we're combining this one here and those 2 to the -1. And that's going to give me 2R over 3. Okay, so those are the resistances of those 4 circuits. And then it gives us a kind of sort of incomplete information. It says one of the arrangements, but it just doesn't tell us which one, has a resistance of 18 ohms, and a different arrangement has a resistance of 8 ohms. So how can we try to figure out which of these arrangements our circuit is in? Well, I think there's probably a couple different ways to do this. I decided, well, let's just start with the first arrangement, and let's assume it's in the first arrangement and work out what the resistance would be. So if we assume it's 18 ohms, and in the first instance, we are told that the resistance of the total circuit is 3R. Is 3R. So in that case, we'd have 3R equals 18 ohms. So that would tell us that R must be 6 ohms. But if that's the case, if I look at the other possibilities, so if R is 6 ohms, then configuration 2 gives me 9 ohms, configuration 3 gives me 2 ohms, and configuration 4 gives me 4 ohms. So there's no way to make an 8 ohm circuit if the resistors are 6 ohms. So we can rule out that 18 ohms is this configuration 1. So what if 18 ohms was this configuration 2? Then we would have 3R over 2 equals 18 ohms. So what would that give us? That would give us R is equal to what? Well, that case, we would get that R is equal to 12 ohms if we solve that equation. And in that case, actually, it makes sense, because if R is 12 ohms, then configuration 4 down here gives us 2 times 12 divided by 3 gives us 8 ohms. So this 18 ohm configuration must be 2, and this 8 ohm configuration must be 4, which means that the ones that aren't listed are 1 and 3. So configuration 1 would be 3 times 8, which is 24 ohms. Which is 3 times 12, my mistake. So this must be 3 times 12, which is 36 ohms. And configuration 3 must be 4 ohms, which is 12 divided by 3. So that's gives us, yeah, that makes sense. So that gives us 4 ohms. 4 ohms. Okay. So now we know the resistances of each of those configurations, and we just need to go through and see which letter that is, and that is D. So that's the correct answer for that one. So I've kind of gone through it, in a bit more detail than you might if you were trying to race through this on a piece of paper. But that gives you a sense that, these are longer questions, and you'd have about 3 minutes to do this in the normal NSAA session. Okay, now let's go back and just finish off a few things in my presentation before we take some questions. So I need to stop my screen share on this device. There we are. And go back to screen share on this device. There we are, example questions. Okay, so I just want to finish off by telling you a little bit about resources that you might be able to use in your NSAA preparation. So some of you may have heard of this online resource called Isaac Physics. And that URL is just isaacphysics.org. This is actually a website designed and created by a member of Corpus Christi College. And it's a website that's now, I think, has somewhere around 3,000 or 4,000 different questions in physics, mathematics, and chemistry. And they're available at different levels. So right from sort of simple GCSE up to first year university, and it's organized by topic. So, kinematics, chemical reactions, trigonometry, etc. So if you want to find some good practice questions, you can go on this website, choose the appropriate level. So if you're trying to revise for the section 1 part, it's all GCSE knowledge. Choose those questions which are at a GCSE level and try working through them fairly quickly. And then section 2, that's obviously at a little bit higher level, so AS level material. That corresponds on Isaac Physics to levels 3 to 4 problems. So have a good look at that bank of questions. That's all free and available online. Anybody who's thinking more about engineering rather than natural sciences, you have a similar sort of assessment called the engineering assessment. There you can go to a website called iwanttostudy.engineering.org. It gives you lots of practice questions in things like mechanics. So make use of those resources. For chemistry, the Isaac Physics website, which has chemistry questions, is quite good for GCSE level. If you want to go and have a look at slightly more challenging questions, and these would be probably equivalent to some of the more difficult ones that you would see, difficult topics, say in section 2 of the NSAA, you can have a look at this Cambridge Chemistry Challenge, the lower 6th competition. I think it's called C3L6. They've got some good chemistry questions available online for you to have a look at. Probably actually maybe a little bit beyond the NSAA level, but certainly comparable to what you might find, say, in an admissions interview. So that's another place you can go to find content. For biology, the biology questions on the NSAA tend to be a little bit less about problem solving, like we've just seen in physics, and more about really mastering that content. So I would say the best choice of revision materials for biology, revise those notes from GCSE, and look at your AS level material. And really for all sections, do try these past papers under time conditions so you get a sense of that time constraint. Okay, so in summary, before we take some questions, now is the time, I think, to start your revision. As I said, these tests are November 3rd. So you've got just over a month, and I think it would pay dividends for you to start your revision now. Do make sure you're registered, and again, your school can help you with that. Spend time familiarizing yourself with the format and looking through that specification document I told you. And finally, do practice those past papers, especially under the time conditions, because time pressure is the main thing that you have to think about here. Great. Okay, so I think that's pretty much all I wanted to cover in my presentation. Now, I'd be very happy to answer any questions you might have either about the NSAA or anything to do with NST or the admissions process.
Thank you, Michael. Looks like we've got the first question in the chat there. I was wondering, how different is the new section 2? It was short answer questions before, and now it's multiple choice. What does that mean for the content?
Yeah, good question. So it used to be like short answer, like you'd actually write out, physical answers on a piece of paper. Now it's all multiple choice. The content is exactly the same. So it's drawing again from that sort of AS level knowledge. But the questions are designed to have a very clear right or wrong numerical answer, just like that resistor question that we worked our way through. And that's more kind of applicable to that multiple choice format. So yeah, in terms of the specification, it hasn't changed very much. It's still that AS level material, but the style of question has just slightly been altered. But have a look at the past paper, the one in 2020, because this year's paper, the format is the same, and that'll give you a very clear idea of what's being asked.
And would you recommend that they use any older section 2 to practice as well, because it's the same content?
Yeah, I mean, it's a good point. So I would say the older section 1s are pretty good. Those are multiple choice. So the content hasn't really changed so much in section 1. It's all GCSE stuff. The amount of time that you spend on section 1 has changed slightly. So you used to do 3 out of 5 rather than 2 out of 4 sections. So if you go and try to do the old section 1s, those questions will be very similar to the new section 1s. For section 2, as we just discussed, they used to be written answers, but now they're all multiple choice. So if you're going to go and practice, I mean, I think the style of questions will be similar, but they'll be tweaked in this round so that there'll be a very specific answer that you can tick a box on a multiple choice form. So yeah, I guess my short answer is section 1 hasn't changed very much. Section 2, the style is slightly different. So just be a little bit wary of those questions.
Great, thank you. And then just in case I haven't mentioned this before, we do have the Q&A function as well. So feel free to pop questions in the chat or in the Q&A function. Yeah. So the next question is, how is the NSAA marked? Is it worth writing out our thought processes so you can see how we got the answers?
Yeah, it's a good question. It's just multiple choice. So you don't have any opportunity to share your thought processes, right or wrong, with us. It's just that bubble that you tick. So it's a strict multiple choice exam. Now, if you were called to interview, then absolutely, those questions are much more open-ended, and we're really interested in seeing your thought processes. So in an interview situation, yes, tell us your thinking, how you're approaching a particular problem, and we're very keen on seeing that. In the NSAA, it's just a bubble. You just color in the circle. So no opportunity, I'm afraid, to share your thought processes.
And then for a natural sciences application, does it matter if you pick the same subject for both sections, or should we vary choices?
Yeah, I mean, I don't think it really matters. My advice is just do the subject that you're interested in the most. And lots of people come into natural sciences being, say, equally interested in chemistry and biology. And if that's you, then yeah, do section 1 chemistry, section 2 biology. If you're equally interested in both those and you think those are your strengths. But if you come into it and you think, I really just want to focus on physics, then do section 1 and section 2 physics. So play to your strengths there, I think.
Great. And then there's one last question in the Q&A that's more about what you research. If you want to take that, that's up
yeah,
to you.
Sure. I'll take it. Yeah.
So you briefly mentioned that your research on electron behavior at lower temperatures and magnetic fields. Are you talking about superconductors? The student was researching something, and it sounded familiar.
Yeah, absolutely. So superconductors are a big part of my research. So these are materials that when you cool them down below a certain temperature, they lose their resistance. So thinking of our resistors that we were just talking about, their resistance would be completely zero, which means they can conduct electricity without any dissipation. So if you have a superconductor, you put some current in a ring, it will flow until the end of the universe. It never goes away. Now, these are very mysterious materials with all kinds of really cool applications. Magnetically levitated trains are one. MRI machines are another. The problem is that most of them only work at really low temperatures. So, almost absolute zero. And nobody really understands why a superconductor works. And so there's lots of great theoretical questions to be answered there. So that's, a brief overview of my research, but come to Cambridge and do a summer project with me and you'll learn more.
And then I think this probably will be our last question, but do the subjects we do in each section determine what types of questions we get at the interview?
No, not really. Different colleges will run their interviews in a slightly different way, and you can find information about this on the website. So at Corpus, we ask you to sort of declare your strengths as being either biology, physics, or chemistry. If you choose biology, you'll get 2 interviews, both of which focus on biology. And it doesn't really matter what you answered in the NSAA, they'll just be biological interviews. If you choose chemistry, you'll get 2 chemistry interviews, physics, 2 physics interviews. Other colleges, if you're interested in physical natural sciences, you might get a mix of chemistry and physics questions. And you can just ask the college you're interested in applying, which model they prefer. I think most colleges would give you a mix, and Corpus allows you just to choose one. But what you answer in the NSAA doesn't really influence all that much what comes up in an interview at Corpus. We tend to ask all the questions, say all the students applying to physics, more or less the same questions.
Perfect. And we determine, just to add on to that, we kind of determine which one you'll be in based on your application. We also ask you, after the application deadline has passed, you'll get an email from me, just double checking that I've put you in the right science. But yeah, thank you guys so much for coming. Thank you, Michael, for your time as well. I'm going to pop the email in the chat here. So if you do have any follow-up questions, you can email the admissions office. I'm always around to help. I do want to also let you guys know about the upcoming deadlines. So the deadline for the application this year is October 15th, and the deadline for registering for pre-interview assessments is also October 15th. So make sure you have that day circled in red in your calendar, or you have it typed into your online calendar, whichever you prefer. But thank you so much for coming. Again, thank you to Michael, and have a great day, everyone.
Great. Thanks, everyone.